It is often the case with AI that we worry about the science fiction future and forget about the actual present. It's unfortunate that in AI we ask the question, when will we hit a bar? So in comparison, we never go and ask an astrophysicist, when will you be done? We'll always study something, right? So AI is like that. It's an open field that we'll keep studying, and there is no end to it. And I don't think there should be an end to it.
Thank you. It's a pleasure and honor to have you on Change I Am Possible, which is India's first future tech podcast. So Dr. Subramanian Ramamoorthy is a professor and personal chair of robot learning and autonomy in the School of Informatics, University of Edinburgh. He is an executive committee member for the Edinburgh Centre for Robotics. He received his PhD in electrical and computer engineering from the University of Texas at Austin. He has been elected member of the Young Academics of Scotland at the Royal Society of Edinburgh and visiting professor at Stanford University and the University of Rome La Sapienza. He also serves as Vice President Prediction Planning at 5AI, a UK-based startup company focused on developing a technology stack for autonomous vehicles. His research focuses on robot learning and decision-making under uncertainty, with particular emphasis on achieving safety and robust autonomy in human-centered environments. Thank you. It's a pleasure and honor to have you on Change I Am Possible. The intro I gave is what I took off the net. So we'll appreciate if you could share your journey in your words in the world of robotics and what excites you most about the field of robotics.
Firstly, Eddie, thank you for having me. These are indeed exciting times to be a roboticist. So to give you a little bit of perspective, 15, 20 years ago, when I used to tell my friends that I work in the area of artificial intelligence and robotics, people would ask me, why don't you do something else? And these days, I find myself not having to explain myself at all. I even have had Uber drivers in random cities understand roughly what space I'm acting in. So the most exciting thing about being a roboticist today is the fact that people understand it. Now, robots have always been in the movies. If you watch Terminator, if you watch a whole bunch of sci-fi movies, depending on what's your favorite, they're there. But actually, that's not the most exciting bit, in my opinion. So what is most exciting, in my opinion, is that the kind of cognitive capacities that young infants have. You know, if you think about everything that we achieve between 0 to 3 years of our life, that is far more exciting from a learning and autonomy point of view than a lot of other things that we attribute to older people. So what's most exciting at the moment is that it is indeed becoming possible to capture some of those capacities in machines. So we are able to build machines that not only do something, and machines are now fairly capable. So we don't just need kind of robots in the factories. Now robots are out there. You have field robots in various places, from volcanoes to cars to to the home, and they all do something, and they're generally fairly competent. What's exciting now is the fact that they can learn to adapt, and so they can cope with a changing environment. So ultimately, they can have long-term kind of persistence in an interesting way.
Right. Yeah. So yes, you rightfully pointed out that suddenly, the world has got like really interested in artificial intelligence, robotics, or anything basically which has got to be frontier technology. And I guess thanks to it's because of COVID that suddenly there's a spotlight on frontier technology. You said your cabbies also. Now everybody knows about artificial intelligence. So yes, there is a lot of hype which the media has created. So what's the current landscape when it comes to robotics? So can you filter out the fact versus the fiction of what AI can do right now, or robotics? Where does it stand at this point in time?
Yeah. That's an excellent question. So let me do it this way. So let me say what it can, and then let me say where there's still scope to improve. So what can we do? If we can define the task in a well-scoped way, somewhat narrowly, actually artificial intelligence and robotics is making spectacular strides. So depending on which part of the media you're paying attention to, so machine learning has been going from strength to strength. So language understanding, machine translation, very recently, even things like predicting biological phenomena like protein folding. So there's a lot of activity that's going on. And the key feature of each of those is that it's a very narrowly scoped well-defined problem. It might be a complex physical system, but it's extremely clear what we are doing and what we are not doing. And likewise, in the physical world, there are, to give you just some hand-picked examples, there are mines in Australia that have autonomous kind of entities. So in fact, there are no human operators inside this mine, and all the human operators are something like 200 kilometers away, sitting in a remote control station. And so that's a huge achievement, the idea that you can just have autonomous machines running the whole place. Likewise, we have robots that are making their way into healthcare, so in hospitals and so on. That's something I'm extremely excited about, and maybe we can talk a little bit more about that in future. And then there are, of course, somewhat more mundane-looking autonomy, but the idea that an Amazon warehouse today might only have less than 10 people, and almost all of it is automated. That's huge for businesses, because previously, if you think about it, there would have been a lot of people acting in these places. Now, my last example also brings up some questions about then what is the role of society, but we'll come to that. But the place where I think that there is still tremendous scope for improvement is as soon as you start opening the box and ask for some degree of generality in the task. So a good example is, for instance, autonomous vehicles, where the underlying technology has been maturing and becoming spectacularly well developed, but we are still quite far from full autonomy as we had hoped. We are not ready to just go to sleep in the back of a car and let it drive itself. And most of it has to do with the variability in the environment, the long tail, as we call it in the trade, where very few random events might still happen and have a very negative consequence. So we don't know how to kind of very quickly adapt to these kinds of things, which is an uniquely human and animal ability that is missing in this area. And likewise, any problem in which you need a lot of creativity in setting up just what the objective is, AI is not quite there yet. So that's where I think the frontier of research would be.
Right. Yeah. So you pointed out towards GPT-3 and protein folding, the AlphaFold, DeepMind 2, what they're doing. Yes, I mean, yes, there is some really, really crazy things, happening in the world of AI. But you are still not seeing these real world use cases which is benefiting the mass. So you had robust autonomy decision group at the University of Edinburgh. So could you share your work there, updates on what you've been building?
So as the name suggests, we've been always interested in this question of what would it take to make a system more robust. So this evolved in a number of different ways. A lot of my early work was in thinking about, so I'm trained as an electrical and computer engineer, and I've been thinking about control systems, which is a very well-established classical engineering field. And much of robotics and modern machine learning builds on top of these ideas. So our first attempt was to ask, okay, what would it make to take these controllers as we deploy them and make them a little bit adaptive? So how do you, for instance, cope with the fact that you're lifting an object of a different weight? Maybe your hand is different from the one you were. And then that slowly morphed into us thinking about human-robot interaction and collaborative systems. So you might be, for instance, a factory worker in a car factory, and then the robot is lifting up the car while you go underneath and fix something, right? So this has to be tightly cooperative in the sense of like getting the timing right and everything. It also has to be robust enough that the guy will agree to go under the car and trust that the robot won't drop it on top of him. If you think about it, it's not easy to reach that level of, the designer trusting that, yes, this is a safe thing to deploy, the worker trusting that, yes, I will work with this. And this has many different pieces. So one technical problem we worked on is this idea of recognizing intent. So, if I just say, please pass me the salt, and you start moving your hand, I have an idea of what you're going to do next. And this is the same thing if a car is driving. So I have a very good idea of, will you change lanes? Should I slow down? Are you going to cut in front of me? These are all kind of important prediction problems, right? And so we worked a little bit on that. And more recently, we've kind of taken on a fairly fundamental question for AI, which is, how do you understand the physical world around you? So we're working quite a bit with medical people, people in synthetic biology, and so on. And in all of these cases, we want the robot or the artificial intelligence system to have an understanding of the underlying physics. So, if this is soft tissue, then it will deform in this way. If I see this anomaly, then it means that there is this underlying condition. Or, if you have this kind of, so in synthetic biology, it's becoming possible to change the genome. So what should you expect will be the growth pattern, and can you think through this? So in all of these, we want to have machine learning systems that have all the benefits of neural networks and good perception and so on, but also the physical understanding of this is how the world works, and I can somehow incorporate that. So for me, that's the most fascinating frontier because it encompasses everything else I told you before. So intention recognition is, if you like, a simple version of understanding the physics of the world. Understanding a different driver on the road is understanding a kind of active version of their physics. So that's the kind of problem we're looking at. And in our view, once a learning system has this level of knowledge incorporated within it, it will begin to have the common sense that then makes it robust.
Right. So what's the timelines, for having a robot which has human-like capabilities? What's the timelines according to you? And could you share, I know this is extremely vague, but could you share like a brief overview on the mechanical engineering and AI architecture that goes behind in building a robot?
I mean, the answer to your question would depend very, very heavily on the operational word there is like. Human-like, right? So we are very far from building a system that's exactly like a human. On the physical side, we don't even understand how to build such a system. And even on the cognitive side, there are huge gaps in our understanding of generalization. But if you were to interpret human-like in a slightly broader way, and then if you were to look at individual capacities rather than the full human, then things are becoming possible. So to give you some examples, let's take intelligent prosthetics. So it is a well-established field for some time now that if you lose a limb or some capacity, then it's possible to build an artificial version of it and incorporate it with you. And this kind of nicely blends the two things you're asking. So it has to physically make sense. It has to be something that you're willing to add to your body. And it also has to have enough adaptation that it would make, it would be easy to use. So if we can constrain it in specific ways, some of this is beginning to happen. So people are wearing pacemakers, people are wearing artificial legs. And so these kinds of exoskeletons is another example. So people are beginning to wear those kind of devices. But then what is unfortunately the case is that all of these kind of physical side of intelligence is separated from what we would otherwise think of as cognitive intelligence. So we have, spectacular agents that play games, provided they are virtual, but somehow those things don't translate very well to then sitting on top of the prosthetic device. So the device doesn't actually think in real time about actually what you wanted was to just kind of, pick up the salt in this way and not that way. And we're still quite far from that kind of intelligence, right? So I think bits and pieces of human-like capabilities are becoming possible. There are some very fundamental limitations that are even outside of robotics proper, if you think about it. So to have high-density energy storage or actuators that can mimic the form of human tissue, it's only we're literally just scratching the surface. So the other day I was watching a video of somebody who's synthesizing plastic that can heal in the sense that if you poke a hole, then it will kind of come back. Now, even a small child takes it for granted that yes, they'll get cut, they'll go to their mom, and then soon the wound will heal. But we don't have machines like that yet, right? So that's such a simple piece of being a human that we don't have that. And so this idea of like taking chemistry, biology, physics, integrating it with AI, the full beast will take quite a while, in my opinion. But pieces are coming, kind of beginning to come together, and these are exciting times to be working on these things.
Right, I completely agree with you. There is so much which is happening. But the only thing, from my vantage point, I see is that people are working in silos. When all of these exponential technologies has got so much potential to completely create transformation. And if everybody comes together and creates a platform which is more open, where there is people or researchers from anywhere from around the world could kind of like put in their bits and pieces, then I think there could be faster acceleration of understanding of these technologies and growth. So I am obviously extremely positive about where this technology is going. But at the same time, I know that technology is a double-edged sword. So I'm also scared with the current state of innovation, in the field of robotics, because you also mentioned exoskeleton, then there's this defense side, the military, which is using, autonomous drone, military robots. They were talking about bionic super soldiers and stuff like that. So do you see robotics, once it matures, do you see it intensifying an arms race?
Yeah, this is it's a big question, and there's no easy answer to this. So let me start by saying there's a lot of regional difference in the context of how robotics technology is developed. So, for instance, I did all of my graduate studies in the US, and there much of the funding that went into creating this industry came from the defense sector. So DARPA is one of the biggest kind of proponents of AI and robotics in the US, and clearly they have a kind of defense perspective. Then there are other countries where the driving forces are an aging population and healthcare and so on, and so the nature of robotics looks different. So I don't think the future needs to necessarily look bleak. I mean, it is very much in our power to determine what kind of a future we are working towards. But that said, I think it is often the case with AI that we worry about the science fiction future and forget about the actual present. So what I mean by that is it is well understood in the machine learning sphere that most of the harms that people are facing are from the application of existing machine learning, not very futuristic technology, but its application in a social setting and an organizational setting which hasn't been well thought out. So there are lots and lots of examples these days in AI of algorithms that are making crucial decisions about social justice, about healthcare delivery, about even simple things like can you get a loan. And the real problems are more along the lines that the ethics that a human practitioner might exhibit in making these decisions, they don't easily transfer into the machine. And in fact, we can show that a lot of these models are obviously biased and obviously distorted. So already there's a danger of, how do we want to deal with this? How do we want to contain machine learning and constrain it in such a way that it reflects our values? And now if you were to put something like this into a physical body, leave it alone, and let it integrate into society as we are envisioning, then all of this only becomes amplified even more. So imagine that we are in a far future like they show you in the movies, where you have an aging population, which is common in the Western world, but also happening in the developing world. And then you have robots that are taking care of them. Now, it's not just kind of the physical side of will it do what I want? Already there are concerns there. It's also, will it then behave the way I want? Will it kind of mess with my life in various ways? And it is quite complex. So already, to pick a very practical example that I have a deep understanding of, I've spent the past 4 or 5 years working with a team where we've been working on autonomous vehicles technology. And so we've intimately engaged with the process of certification, what legal regulation should look like, and all of that in this setting. And we see that what I mentioned earlier, this long tail phenomenon, as we call it. So, which is, if you look at the distribution of events, then there are a lot of events in the middle of the distribution that are fairly normal, and then there's like this tail of events that are very rare and very peculiar. It's very hard for us to determine these unknown unknowns. And if we can't determine them, then we don't know with what confidence we can deploy the system. So there's a lot of effort that's being put in at the moment in trying to constrain the scope such that we can actually deploy these systems.
Right. Yeah. So again, I'm so very sorry. I'm going to go back to the earlier question, the first part of my earlier question. Yeah. Can you share like a brief, basic framework of what it takes to build a robot? Like the mechanical engineering part or the AI framework, like the basic overview on building a robot.
Yeah. Okay. So let me take one example. So we have a couple of different robots in my lab. And the simplest way in which one might start to set up a lab would be, it's possible to go out and, if you like, buy commercial versions of robot arms, or you could build these as well. So when I say a commercial version of a robot arm, anything from sort of my shoulder to the end, and they will look just like the standard robots you would have seen in a car factory or something. So they're essentially, the choices are, what would your mechanical construction be? How do you want to keep it lightweight and repeatable? Repeatability is a big issue. So it's not just that I constructed something, but that if I keep using it, it will move in the same way again and again, not drift. And then you have choices on actuation. So is it going to be electric motor driven? Is it going to be hydraulic? And then this has a bearing, because at the moment, if you want really fast explosive movements, then actually electric motors may not be your best, and maybe one of the other actuation modalities would be. But on the other hand, if you want to interface it with a computer and kind of work well with it, then electric motors might be better. So there's all of these kind of choices one makes. Then there's the choice about body. So what do you want to do? So I just told you about two arms. Do you want to make it humanoid? Do you want to make it four-legged? Do you want to put it on wheels? And we have all of these robots in our center. So we have humanoid robots that are literally human size, double the human weight, because that's the only way the materials can be procured. And then we also have other kind of entities. So we have two arms that are mounted on a ceiling because we use them in a surgical theater-like setup. And then we have mobile robots that are just on wheels and that move around in both indoors and outdoors. And then all of them have to be somehow standardized so that it's possible to apply computer science on it. So the standardization actually comes through a process of thinking about a middleware. So one very popular middleware in the robotics community today is called ROS, which stands for Robot Operating System. So what this has done is abstract away the physical layer that's underneath it from everything from above. So from above, it looks like I get input from a sensor, I make decisions and send it to an actuator. And so it looks like what a computer science or electrical person is familiar with. And underneath, on the other side of the operating system, is all the fancy mechanical hardware and peculiar drivers and so on. So if you were a roboticist, you would sort of make choices about where you play. But in order to build a full system, you would need people who understand the mechanics of it. How do you make it lightweight? How do you make it robust and reliable? People who understand the embedded system side of it, so the middleware and software like that. And then people who understand the decision-making and planning and learning side of it. And there it's typically kind of software packages that look pretty similar to the rest of machine learning.
Right. So amongst your peers' work, whose work seems to be the most promising and why? And from I've seen a couple of robots, at Boston Dynamics, I think is doing very cool, Sophia robots. But there's one which has really caught my attention is this startup from Canada called Sanctuary AI, which is headed by Suzanne Gildert. And I think she's doing a fantastic work. So what seems to be, according to you, the most promising robot and why?
Yeah, this is a very difficult question. This is a bit like asking to pick a favorite child. Right? But more so because I think it would be very hard to pin it down and say I like one. So maybe I can give you a few different answers and then we can riff from that. So as you mentioned, Boston Dynamics is an excellent example of a robot system that I have long admired. So I wrote my PhD thesis on problems that arose from the control of walking systems. So for me, Boston Dynamics was always somebody to look up to, and that whole group, Mark Rabert and the MIT Leg Lab and what it became in the company, they're a spectacularly skillful set of engineers. And what's really remarkable about them is that they have single-mindedly gone after this idea that, I want to replicate these capacities from the human, kind of everything from how your legs are constructed to how the nervous system actually accesses it. But then they've done it in ways that would be very familiar to a good engineer. So they haven't just obsessed about, am I bio-inspired or not, and things like that. They've said, no, this is what it takes to build a good system, and I'm going to build it. And the results are clear for everybody to see. They're miles ahead of any other system that looks like them. And in their most recent kind of offerings, you see a diversity between a robot like Atlas, which is really at the frontiers of research, but not quite deployable, one might say, because it's really a research system. And on the other end, you have robots like Spot that are very, very robust, that companies are using, that you could buy if you had $75,000. So that's spectacular. But that's only one side of robotics, and that's the physical side of robotics. I would say there are many, many exciting companies on the other side that are thinking about how precisely to deploy the robots. But here I'm at a loss because I can't just pick one company and say there it is, because it's actually an evolving space. So one could pick the well-deployed systems like what's happening in warehouses. So there's a UK company called Ocado that's very interesting. It's very interesting because not only have they done the robotics, and they do a good job of kind of automating essentially an entire grocery store, including the warehouse. So if you were to place an order through several of the big grocery chains in the UK, it's fulfilled by Ocado and fulfilled by their robots, really. So everything from picking your tomatoes from the shelf, putting it in a bag and shipping it off, it's all automated. So I would say that is really, really interesting because it's not science fiction robotics. It's not kind of a humanoid robot doing a backflip, but it is something that I can go on the internet, click, and know that the whole thing was delivered by a robot. And so I think that's really interesting. But then if I could kind of add one more thing to this, my own personal favorite domain, this is where I'm trying to do more and more work, is robotics in healthcare. So there's been a long-standing kind of interest in this. There have been well-established companies like Intuitive Surgical is one of the dominant suppliers of robot surgery platforms. But also more recently, companies like Google have played in that space and in collaboration with Johnson & Johnson. And there's now a UK-based company called CMR, Cambridge Medical Robotics. So like this, there are a number of these companies. And what I find exciting about this space is that it's becoming possible to take the kind of, what I've said before, physical and athletic abilities in these robots and marry it with cognition in a way that actually is demanded by the application. So we are trying to work with surgeons at the moment, and we are trying to see, is it possible for us to build systems that not just kind of get forced upon you, but help you do something you never could do before? So we are asking questions like, is it possible to automate bits of tumor surgery such that we can give you higher precision of excision? And that will directly translate into, will you live longer? Will you have higher outcomes? So for me, that's the most exciting space when it comes to these kind of applications.
Right. So would you like to talk more about what you're building? You said the healthcare space, the robots that you're doing. When do we see that going out to the market and its capability?
Yeah. So maybe it's a bit too early for me to speculate about when exactly that will go into the market. But let me describe a little bit that space.
Okay.
There's an established tradition of people who've been building, soft robots and various kind of robots that can somehow, engage with the human body. It could be that you're doing minimally invasive inspection, or you're trying to do bits of surgical automation. And what has happened is that people have looked at it exactly like we were talking about it. Some people look at the mechanical engineering, as in, can you make it more compatible with biological operation? And some people have been looking at imaging and saying, can you do better diagnostics? What we are trying to do in some of our current work is to bring these things together. So we are trying to ask, so if you go back to my earlier thing that I said about how kids are very good at learning, we would like to take basic capacities, like, if I show you some tissue and then I say, feel it all over, look for how it feels, and from that tell me what's going on. So we learn this very early on. If you're an expert surgeon, the first thing you do when you go to a doctor is they kind of feel around, say, so what's going on. But robots are not very good at this. And if you then take it to the next level and say that a robot is going to use all of its sensory capacities and kind of diagnose in real time so that the surgeon can do better, those kinds of capacities are only now emerging. So what we are doing is kind of engaging with this in small pieces so that when they'll eventually be brought together. So we're working with some people on the diagnostic side, where it's mainly a machine learning heavy problem. We are working with some surgeons on whether we can do those physical activities and do what we call an inverse problem. And we are making progress with that. So what I would expect is that in the beginning, the deployment of a lot of this technology is going to be as pieces that fit into an existing kind of product. And in the long run, and by long run, I'm hopeful that it will be 15, 20 years or before my productive career is finished, I would like to be able to deploy a full system that actually performs a meaningful big chunk of something like cancer surgery.
Wow. We wish you the very best for it, right? So, going back to Boston Dynamics, Boston Dynamics obviously is pushing the boundaries with robotics. But if you go to see, it's still lacking business use cases and it's not making money. In fact, SoftBank recently, I think, is selling out Boston Dynamics to Hyundai Motors. So then there are these Chinese startups, that maybe they back engineer or they've got some really good engineers. They are building cheaper and better robots. For example, you said the Boston Dynamics Spot Mini is going for $75,000 USD. At the same time, Unitree is a company out of China which is selling almost the same for around $10,000 US. Yeah. So do you see the future being more democratized, where information is out there, there's more engineers, there are more computer scientists who come together, who build fantastic products which actually solves problem and is ready to go to the market, rather than these big companies who have obviously spent billions of dollars in research but they don't have a product yet, which is go-to-market product. What's the future roadmap of robotics?
No, this is an excellent question. And this is what, often we get caught up in the science fiction capabilities and forget about the fact that for the industry to survive, there must be near-term use cases. So this is where I would point out that, some of the early examples I gave you, like, automating field operations in a mine, or let's say just, tending machines, maintenance and things like that. All of those are meaningful use cases. So there was a company that was set up by Rodney Brooks a few years ago called Rethink Robotics. They made a very low-cost, relatively low-cost robot called Baxter, which cost about $30,000. The interesting thing about that was that it was explicitly priced and designed in such a way that it could fit into the end of an assembly line and do something useful, or a delivery line. Right, so people have been thinking about these kinds of things, and if you ask, certain set of roboticists, what's the most successful robot company, they might point at iRobot, which makes home vacuum cleaners, and in the beginning there was only one, and now Dyson makes them, and there are lots of Chinese companies making them. So that's exactly how it would go, and I would say from a business point of view, it's a very good thing that there's this diversity. So if we take as an example, as a comparison industry, consider how semiconductors evolved or telecommunications evolved. It started out with a few spectacular achievements. In the case of chips, the invention of the transistor, the invention of the semiconductor chip, and those were all done by very, very expensive facilities with very few companies and specialists. But soon, once they were packaged, it became democratized. So everybody could work on chips. Their entire countries, like if you think about Taiwan, its economy is primarily boosted by being the foundry for everybody else's chips. And so that happened. And then now the whole industry has matured into saying there are a few small number of basic suppliers who make primary chips, if you like. There are a lot of intermediate suppliers who make special purpose chips. And then there are system integrators on top who would bring them together to make your cell phone, to make your microwave. And so it's a very productive ecosystem in which you don't have to worry about the fact that the other player exists. If anything, you're happy that the other player exists because they are making the whole industry. So I think robotics will have to become like that. So there will have to be a few people who are somehow the primary suppliers of very complex systems. And then there'll be an intermediate layer of companies that are kind of building, high performance specialist technologies where the economies of scale make sense only because there's an overall ecosystem. And then there'll be the specialized applications you're talking about. You see this in many domains of robotics where some maturity is coming in. If you think about autonomous driving, for instance, they've benefited from the existing business ecosystem of automotive companies. So there is the well-established notion of OEMs and tier one suppliers and kind of smaller companies. But also that has meant that you can have a company that specializes in building LiDAR, that you can have a company that specializes in building simultaneous localization algorithms, and then other people who specialize in saying, I want to deploy grocery delivery. So that's probably the only way such big technologies can be deployed.
Right. So India has quite a lot of robotic startup. It also has, since you're looking at autonomous vehicle, it also has some autonomous vehicle startup. In fact, Swayat robots, robotics, they're going for level 5 autonomous vehicles, and they're doing a pretty good job at it. Would you be open for partnering, creating collaboration, mentoring Indian either robotic or autonomous vehicle startups?
Not just autonomous vehicles. I'm generally very open to working with more people in robotics and AI as a whole. I mean, as I grew up in India and I have strong connections with the country, I have been trying actively to reach out in the past few years and try to get connected with various organizations. So recently, my very last trip that I was allowed before the COVID lockdowns began was to IIT Delhi to work with some colleagues there. So they kindly invited me to a workshop, and we were talking about exactly how could we work together. And it was very interesting because it was just a 2-day workshop trip, and I only had a kind of a little bit of time to talk to people. But already in that time, I met, I think, 2 or 3 very bright people who had their own startup companies and who were telling me about their ideas. That's exactly what you want to see. And I'm very keen to work together with all of them. So there are multiple ways in which this could happen. So I work in a fairly large established university in the UK. So we have a mature understanding of how to work together with our counterparts. So certainly India has very strong universities, other kind of research labs, everything from TIFR to NCBS, and we are very open to collaboration with them. We already do. But that's only a very small kind of piece of the puzzle. I think the more exciting opportunities are to engage with the broader set of people who are thinking about new ideas that we wouldn't see inside the university sector. So I would be very keen to, for instance, speak to people who, because of the uniquely Indian context, might have application ideas, or this could be anything from field systems to do something. It could be healthcare delivery in a different way from how the Western world does it. It could be a variety of these kind of systems. And I think there's plenty of scope, and I would be very keen to engage with such people.
With my podcast, I interview people, front runners who are doing some exciting stuff in the frontier technology. And thanks to internet, I think it's created this new breed of entrepreneurs who are audacious and have a bold vision. So Change I Am Possible is a platform for those few entrepreneurs who go out there and are trying to solve really big problems. Yeah. So yes, I mean this I'll leave the note behind, and maybe you can connect with a couple of startups. So you are also the VP at 5AI. So can you share your role and what you're doing with 5AI?
Yeah. So let me say a bit about the company. So 5AI is one of the few companies in the European context that have gone after the full stack of autonomous driving. I have been in a very special arrangement. So for the past 4 years, I've been part of the company, and the arrangement is that I have taken a long-term leave of absence for 50% of my time from the university. So I've been able to split my time between the company and the university. So for the past 4 years, I've been an executive in the company. When I joined, I think there were only about 10 people in the company. Now, we are much more than 100. And more importantly, I've kind of participated in the building up of a stack. We did road trials in London where, we had the car autonomously drive for large stretches of a populated city, which is still a spectacular feat engineering-wise. In terms of what this actually means for robotics, what this has taught me is the full process of not just building the core technology, but what would it take to build a team to build that technology? What would it take to have conversations with regulators and kind of external organizations for doing this? And so sort of the last question that we were probing, which is, what should the industrial ecosystem look like for something like this to succeed?
Right. So currently, most of the robots, whether it's the Sophia robot or whatever, it's largely controlled by a human. When do you think we'll see autonomous robots? And what will the world look like when we actually have autonomous robots?
Yeah. So I think that it's important to recognize that the famous kind of media-friendly robots are the ones that are mostly teleoperated and remote controlled. There are a lot of autonomous robots out there if we broaden the scope of what we are looking for. So I mentioned vacuum cleaners. And so the most interesting achievement is exactly that those machines are left in regular homes to just do their thing. They don't do a lot, but they're left alone to do their thing. And they do it for months at a time. So there are examples. But maybe that's at the borderline of what you would call a real robot. And then you look a little bit above, and if you look inside, let's say, factories or mines or hospitals, there are a lot of mobile robots that are left autonomous for periods of time. So it's not as if this robot is never controlled. It is more that I'm okay to let it do its thing for some time, and it knows how to ask for help. So that would be the paradigm in which these things work. So we will begin to see lots of these small, almost things we don't pick up as robots that will suddenly then grow up to have the capacities of, more interesting looking robots. It will take some time in the highly safety critical applications for us to gain trust. Simply because there are very basic scientific questions that must be answered about robustness and how we're going to deal with it. But that's fine because that's at one end of the spectrum. There are other applications that are not so safety critical. So for instance, yes, I'd be a little bit annoyed if maybe my vacuum cleaner got stuck under my sofa or made a scratch, but it's fine. I mean, it doesn't hurt anybody else. And like that, you can think about a range of applications which are kind of moderately complicated, where I would expect to see robots come. And I would say this is exactly how AI technologies have developed. If we had insisted from the get-go that machine learning systems were perfect, it would never have gotten anywhere. So, if you've ever tried talking to your home conversational agent, whether you like Alexa or Google Home or something like that, its reliability is really quite bad when it comes to the conversational layer. It's extremely good at speech recognition, but I mean, you can get hilarious answers out of it. And if you've seen kids interact with these machines, they sit there all day and probe until they find the right kind of bizarre behavior. And likewise, if you go on Google search and search for something, and it's pretty common that it doesn't have any contextual understanding of why you're searching for it. So what I'm trying to point out there is it's important that there are that there is a spectrum of applications in which the demands are more forgiving in the beginning and then stringent later on. So right. That's how I think robotics will also get deployed.
Right. So when do you see an intelligent robot? When do you think that's going to happen? And, people are talking about artificial general intelligence. Will artificial general intelligence require embodiment?
Yeah, this is a deep question. question. Firstly, I should say that I personally am a bit uncomfortable with the term artificial general intelligence because I come from the school of thought where I always thought artificial intelligence was meant to be exactly that.
Exactly.
And I mean, we don't need to rename it. But at the same time, I also take the view that these are not binary decisions. It's not AGI or nothing. It is more that I like to think about it a little bit like how we think about the basic sciences. So it's unfortunate that in AI we ask the question, when will we hit a bar? So in comparison, we never go and ask an astrophysicist, when will you be done? We'll always study something, right? So AI is like that. It's an open field that we'll keep studying, and there is no end to it. And I don't think there should be an end to it. But I think your question is more like, what will be the threshold that we need to hit, at which point we will say that we've kind of achieved something that we always thought of as AI? My honest answer is I think that threshold will keep moving generation after generation. So to the original generation, when they first conceptualized the idea of AI, they came up with a set of targets. When will it play chess or Go or something like that? Or, when will it do this and that? And those have finally become possible. But even along the way to it becoming possible, it became quite clear, no, we asked the wrong question. That's not what we meant. And then we said, okay, what about language understanding? And some of the very recent machine translation language model work has made it clear that even that question is a bit delicate, because everybody will agree that GPT-3 doesn't actually understand language in any useful sense. But maybe that's why the question needs to be more precise, because every objective version of language understanding that people laid out, with a few exceptions, is beginning to fall to these kind of models. And so there's two ways to approach this. One can keep kind of looking for that corner case that AI cannot do, which is one way to approach it. But the more useful way to me is to think in terms of, this is an endless journey, and we enjoy the journey as much as the destination. And every generation that comes of AI students, of people, and so on, will look for the next level of capacity that they want to automate. There's plenty that we don't know even how to describe, let alone automate. If you looked at sort of anything that you would meaningfully call creativity, those wild sparks of imagination that happen in mathematics or something like that, or even much more mundane. I mean, if you think about the ways in which kids do, analogy and concept formation from, literally a single example, we can't really do any of that. So we're still far from kind of trying to capture that. But that doesn't need to stop us from developing systems. But to your second part, whether embodiment is necessary, this is actually a question that's being actively debated. I don't think it's very easy to settle this question. If you want to take my view of intelligence, which is that you have to have a causal physical understanding of the world, and if you take this view that intelligence is not that different from child development, then embodiment is crucial, I would say, because without it, you're not going to have the constraints that are necessary to induce useful concepts. You'll just keep inducing kind of random things that don't make any sense. Now, if all you want to do is to kind of play a video game, maybe that's okay. But if what you want are meaningful, transferable concepts, then you have to live in a world, and you have to grow up in that world, and you have to understand that world. So I think embodiment is a key piece of that.
Right. And there is so much fantastic things happening in the world at this point in time. Each of these frontier technologies, right from artificial intelligence, nanotechnology, synthetic biology, quantum computing, augmented reality, virtual reality, mixed reality, brain-computer interface. I think once these converge, I think we're going to get into a world where maybe machines might be doing more, not just of physical work or research work. And I know it might sound a little scary at this point in time, but the things which is happening in the world of frontier technology, really excites me. There is Elon Musk who's working on creating Neuralink, a brain computer interface. There are people working on building virtual reality world, which could be in a couple of decades maybe indistinguishable from a physical reality. There is people working on artificial general intelligence. We are at a narrow space at this point of time. Just recently, I think MIT, an engineer from MIT built an AI that can design its own robots. It's called robot grammar. Now, I I am super excited because I think we're just scratching the surface. And but yes, I know that we need to collectively chart out the path forward, because for the first time I think that we are not on a linear path, we are on exponential path, and I don't think anybody knows what's going to happen next. We are all speculating because I think we are all deeply vested in what we are doing, and whatever everybody is doing is so potential that it can completely transform, maybe burst like a volcano. That's the potential of these technologies. So that's the reason when I was saying that maybe we possibly, or maybe we surely need to come together as a collective and create a platform where all of these frontier technologies, which can has the potential to leave humanity behind, needs to be addressed very carefully. Because yes, we are scratching the surface, yes, we are just trying to figure out what it can do, but I don't think 2 decades or 3 decades is a long time. And I think in that time, all of these technologies, whatever is sounding science fiction, will definitely become a reality. And that's the reason the podcast, that's the reason I try and educate people about the transformational potential or capabilities of each of these technologies. So as a front runner of robotics, what's your prediction for robotics in 2021 and beyond, and what's your future roadmap?
Yeah, I mean, predictions are always difficult, right? Especially in an area such as AI. But let me give you some thoughts based on trends that I'm seeing. I think there's a very strong recognition in the AI community. So I'll give it to you in terms of pieces. So if you talk about the cognitive piece, I think there's a very strong recognition that we've achieved a lot, especially with the emergence of deep neural networks and so on. A lot has become possible on the engineering front, as it were. And all of the next set of questions are about slightly more difficult aspects of cognition. How will you get causal models? How will you do induction? How will you do concept formation? So that kind of thing is happening. I think this next level might actually be a little bit harder than the previous level. And so it's hard to make predictions, but I would not be surprised if it takes 10, 20 years for meaningful progress to happen on any of these problems. On the physical side, it's very interesting because just as the emergence of big compute changed computer science and machine learning in the past 20 years, it's finally becoming possible to have similar exponential growth in chemical and material sciences, biological fabrication, energy storage, all of these kinds of things. So it is only a matter of time. Now, whether it's 10 years or 50 years, we don't know, but it's only a matter of time before all of that has an impact. So for instance, soft robotics is still a rather niche community in robotics. But 25 years from now, I would be extremely surprised if all robots are not essentially soft robots. That kind of thing, it will have a transformational effect on how we do things. So we will look back and say, how did we not do more of this earlier? And so now if you think about the convergence of these things, so if you have a situation in which you have soft biological robots and likewise, synthetic biology and various kinds of biofabrication are becoming more and more well developed. So at this point in time, so when I speak to my colleagues in synthetic biology, we are talking about, can you edit the genome of a bacterium, or can you do this and that? And then everybody fondly looks and says, maybe we can do mammalian things in synthetic biology. But there's going to be a time when all of this becomes fairly routine, and we are able to make meaningful progress in terms of synthesizing what looks like human organs that can be integrated with machines. Right? So this would be the next level beyond prosthetics and so on. So at that point, you're going to have, almost biologically realistic machines that are being put together with the next level of intelligence. And that would be very exciting. It's hard to predict, how exactly that will happen or when. But for the next generation, that's where they should really be looking.
Lovely, lovely. Thank you. It was a complete pleasure and honor to talking to you. And thank you for sharing your insights. And somehow, my perspective, I could be completely wrong. I don't think we humans are much different than machines, because we've got 70 billion neurons and 100 trillion synapses, and they function only because of electricity. Then we've got trillions of cells in our body. Again, it functions with electricity. So somehow there is, but anyway, thank you. It was a pleasure to chatting with you. And to my listeners, if you like what you see in here, please press the subscribe button. Until next time, see you guys. Bye-bye. Thank you.
Yeah, it was my pleasure. Thank you for having me.